In the subduction zone, the overlying continental plate is locked to the subducting oceanic plate by immense friction along the shallow portion of a vast sloping fault surface. Recent GPS data from the Pacific Northwest show that the land above the subduction zone is indeed being pushed backward, deforming in response to the stress. Arrows mark the original locations of the leading edge of the overlying plate and the GPS unit. The plates can lock together until they overcome the frictional stress in a process called elastic rebound. This produces magnitude 8 to magnitude 9 great earthquakes. And if the land is displaced beneath the ocean, as it does in this simplified animation, it causes tsunami. This cycle of locking and building stress followed by catastrophic release repeats every few hundred years.
In this animation, the three grids portray plate interaction and deformation in three zones of a subduction region, which include the lock zone at the leading edge of the overlying plate, a transitional zone that locks for approximately 14 months at a time, then slips back a little before continuing its push inland, and the zone far inland from the locked portion of the plates that sees little to no deformation. The grids below each GPS receiver represent compressional stress on that region. The first graph shows the leading edge of the continental plate is locked with the subducting slab, thus gets shortened, building elastic potential energy. The graph shows steady rate of change as the land is being forced relentlessly inland. It will ultimately release the built-up strain, resulting in a great earthquake. Graph 2 shows the land being forced inland due to friction between the plates, but it occasionally backslides along the plate boundary, releasing some of its stored elastic energy in mild seismic tremors spread over a period of days to weeks. The sawtooth pattern on the graph reflects the forward-backward motion of the GPS station on the surface. The third station does not move, and the grid shows no deformation, so the graph is flat.
If you live in earthquake-prone regions, it isn't a question of if, but when an earthquake will occur. We do not know where we will be when it strikes, but we can know how to protect ourselves when it happens. Here are the best ways to protect yourself when an earthquake strikes. If you are inside a building, do not run outside. Drop, cover, and hold on. Drop to your hands and knees. Take cover under something sturdy and cover your head and neck, and hold on until the shaking stops. If you are in bed, roll onto your stomach. Cover your head and neck with a pillow and hold on. If you are in a classroom, take cover under a desk and hold on. If you are in a lab or other area with chemicals or machinery, be aware of all hazards before you drop, cover, and hold on. If you are using a wheelchair or walker, lock your wheels if possible, then cover your head and neck and hold on until shaking stops. If you are in a high-rise, drop, cover, and hold on. When shaking stops, use the stairs. Do not use the elevator. In a store or where there are freestanding shelves, move quickly to a protected area next to a shopping cart or beneath clothing racks. Then drop, cover, and hold on. If you are outdoors, move quickly away from buildings to avoid falling debris or away from power lines and other hazards. Drop, cover, and hold on. If driving, pull over, avoiding overpasses, bridges, power lines, and other hazards. Stop, set the parking brake. Stay in the vehicle until shaking stops. If you are near a shoreline, a tsunami may be coming. Drop, cover, and hold on, then stand and move quickly to high ground or inland. Stay there until tsunami restrictions are lifted. What you do during an earthquake depends on where you are, but the basics will remain the same. It can be difficult to run or even walk when the ground is shaking. Drop and crawl if you need to move to a safer location. The greatest danger during an earthquake is from falling or flying objects, which is why you need to take cover. Protect your head and neck with your arms or with other objects. Earthquake shaking can last from seconds to several minutes. Hold on for the entire time. For more information on earthquake protective actions and how to get prepared, visit www.shakeout.org.